Welcome to Trigonometric Identities. In this, we will be taking some of these trigonometric expressions and simplifying them using all of the different information we know about how cosine relates to tangent and secant, etc., and going ahead and figuring out how to get it to look like the right side of the equation or just to simplify it in general. So right here, we do need to know the 6 trigonometric functions and how they relate to one another. And so right here, these are all the reciprocals that I'm looking at right here. But since we know that tangent is sine over cosine, we know that cotangent is cosine over sine. Those are really important because some of the strategies we're going to be using is getting things into sine and cosine first. I wanted to look at our unit circle so we could understand how the Pythagorean identities are derived. So right here, I'm just going to make a triangle. And of course, if you've watched my unit circle video, if you filled out a unit circle, you know that this is x comma y. And you know that since the radius is 1, x really is going to be the cosine of this angle, and y is going to be the sine of that angle because sine is the opposite and cosine is the adjacent. And so if you know Pythagorean theorem, which you probably already do, you know that a squared plus b squared is equal to c squared, where c is the hypotenuse. Well, if I go ahead and I look at the different legs of this triangle, so right here, this is our x and this is our y, but really what they are is they are our cosine and our sine. So cosine squared and sine squared equal 1. Do not be confused about this notation. I was confused in high school until somebody really explained it. It's really just saying it's the cosine times the cosine, but the squared doesn't go on the outside. It goes right here between the cos and the theta or the x, whatever the variable is. All right, so since we know that sine squared plus cosine squared equals 1, we can also derive some of the other identities. If I go through and divide everything by sine squared, I'm going to simplify this now using some of my reciprocals. Well, sine over sine is 1. Cosine over sine is cotangent. So notice this is cotangent squared because it's cosine squared over sine squared. And then right here, the reciprocal of sine is cosecant. So we have another identity right here. Now, instead of dividing by sine squared, I'm going to divide by cosine squared. And you can see how that's going to change everything here because now it's sine over cosine, which is tangent squared. And then cosine over cosine equals 1. And then here the reciprocal is going to be secant. And notice everything is squared because we have sine squared and cosine squared, so it's tangent squared. So these are the 3 that you definitely need to know. Now I will say the last 2 I never really quite remember, and so I just write the original and I divide by the sine squared or cosine squared. So that's kind of what I usually do to remember those. But another thing too is you also need to recognize these rearranged. And so here, if you think about this with sine squared plus cosine squared equals 1, I can also say, hey, what if I subtract cosine on either side? I'm now left with 1 minus cosine equals, or 1 minus cosine squared equals sine squared, or 1 minus sine squared equals cosine squared. And again, with the other 2, you need to be able to see those as different arrangements as well. So it's all the same identities, but obviously if I go ahead and rearrange where things are, it's the same relationship. So some of the strategies for simplifying or proving these trigonometric expressions is we want to put everything in terms of sine and cosine. And let me just state too that these are different strategies. You're not always going to use all the strategies. You're not maybe going to even use the first one where everything goes in sine and cosine. It's a place to start until you figure out which strategy is best for that problem. You know, if there are 2 fractions, you can find a common denominator and go and combine them. Lots of times you'll substitute with the equivalent expressions, kind of like what we did where cosine squared is 1 minus sine squared, right? If it has 2 binomials, you can multiply them. If you see something like 1 plus cosine or 1 minus sine or 1 plus sine, etc., sometimes we multiply by the conjugate to go ahead and get those to then be like 1 minus sine squared that I know I can replace. The other thing we can do is we can factor. Yes, we can even factor these. So let's go ahead and take a look at some examples. So right here I have secant minus sine tangent equals cosine. So I'm going to try to make the left side equal to cosine. So I'm going to simplify it to that. And so one of our first strategies is, hey, I'm going to take everything and put it in terms of cosine and sine. And so again, that's usually a really good strategy to start with if you are stuck and don't know what to start with. Because now if I look here, I think, okay, well, this is just over 1, right? I now have cosine as my denominator for both of these. So I can just do 1 minus sine squared over cosine. So I combine the two fractions. And then remember we talked about those Pythagorean identities. Well, right here, remember that is just cosine squared. Oh my goodness, that's right, folks. And then so right here, we just, don't forget the S, we just can cross off one of the cosines and we're left with cosine of theta equals cosine of theta. And of course, the whole time you're rewriting the right side so that at the end you get that full cosine equals cosine. Done. All right, here's another one. And again, one of the best strategies to use is go ahead and change everything into sine and cosine. Now right here off to the side, I'm going to show you, okay, so secant divided by cosine is the same thing as secant times 1 over cosine. Well, we know secant is 1 over cosine, so really I have 1 over cosine times 1 over cosine. So 1 over cosine squared minus, and then over here, if I have I'm going to do this in blue here, tangent divided by cotangent, well, isn't that just tangent times tangent? Really, because the reciprocal of cotangent is tangent. And so tangent we know is sine over cosine, sine over cosine. I know I'm being lazy not putting my thetas, but I'll put them over here. So I have sine squared theta over cosine squared theta. And trying to get this to be 1. Oh, wait a minute. So this is all just one fraction now because it's the same denominator. Super cool. Okay, and then just like in the last one, we can replace 1 minus sine squared with cosine squared over cosine squared, and that is just going to equal 1. And there we go. Yay! Done with our proof. All right, I'm looking at this one, and it has a secant squared minus 1, and I'm thinking back to our Pythagorean identities, and I just want to write down the one that relates with secant. So the one that we looked at before was tangent squared plus 1 equals secant squared. Well, if I subtract a 1 on either side, I do get that that's tangent squared equals secant squared minus 1. Oh, well, maybe that will help us out because then I'm not dealing with 2 terms on the bottom. I'm just dealing with 1 term. And so I have secant squared divided by tangent squared. So maybe let's go ahead now and look at it as being secant squared divided by tangent squared. And so let's see, secant squared divided by, I'm going to write this as sine over cosine. Oops, this is squared. And then I'm going to think about the fact that, secant squared is 1 over cosine squared. And then dividing by a fraction is the same thing as multiplying by its reciprocal. And so I'm writing it like this. And oh, well, what do you know here? We can go through and cross off our cosine squared. So we're just left with 1 over sine squared theta, which we know is cosecant squared. Ta-da! Yay! And there, that looks better. Done. Ooh, okay, so here I have 2 binomials. Well, one of the strategies said, hey, maybe I can go through and just multiply these out. So if you think about it, because one of these is plus and one of these is minus, my inner and outer terms are going to cross off. So I really only need to multiply my first and last. So cosine squared x here minus sine squared x. The right side only has sine and the left side has a cosine. So I'm wondering if there's a way to replace cosine squared with a sine squared. Well, yeah, you go back to cosine squared plus sine squared equals 1. If I subtract sine squared from both sides, right, then I can go ahead and get cosine squared by itself. So let's try that. So 1 minus sine squared x minus sine squared x. And you can see here I'm almost there. It's just now if I combine these two, I'm subtracting it twice. So 1 minus 2 sine squared. Yay! Done. Let's see. Looking at this one, I already have things in terms of sine and cosine. I don't have anything to multiply out. I don't have anything to factor. Well, there was a strategy that talked about if I have like 1 plus cosine or 1 minus cosine, I can multiply by the conjugate. So let's actually try that and see what happens here. So the conjugate of 1 plus cosine, or sorry, 1 minus cosine is 1 plus cosine. And you're going, well, why does that help? Well, then in the denominator here, remember I only have to worry about my first and last terms again because my inners and outers are going to cross off. These are conjugates of one another. So 1 minus cosine squared is going, oops, let me go ahead and rewrite that with some space here. So 1 minus cosine squared, and with an x, is going to be my denominator. And the top, I'm just going to keep as 1 plus cosine x times sine x. I'm not going to go through and distribute that. But what I am going to do is say, hey, you know what? I'm going to go ahead and replace 1 minus cosine squared. And using one of those Pythagorean triples, we know that that's just going to be sine squared. So I have 1 plus cosine x times sine x. You see where this is going now? Yeah, you probably do. This sine x can cross off with one of these. And I have the 1 plus cosine x over sine x. Ta-da! All right, the last one we're going to look at in this video, kind of similar to the one previously, where if I have a 1 minus sine theta, a great place to start is going through and multiplying by the conjugate. So let's go ahead and do that again and see if that helps us. Again, sometimes you try some strategies and maybe it doesn't help, and so you backtrack and try something else. But usually when I see this, that's the strategy I try first. So let's see here. In the denominator, I have 1 minus sine squared theta. Notice in the numerator, I'm not multiplying through anything right now. I'm going to see what happens here. But I am going to look at my cotangent as being cosine over sine. So I'm just going to look at that. Okay, and then there's a random -1. Okay, great. So let's look at that then. All right, so right here, the denominator, 1 minus sine squared, can be replaced with cosine squared. Great. The other thing I'm going to do is this sign right here that's in the denominator, I'm going to put it right here because that's technically where it goes. So I'm going to put it right there. These two combine to be cosine squared theta. And then I still have my 1 plus sine theta. Oh, well, what do you know? That's really nice. My cosine squareds cross off. That's great. Now I can write it as 1 plus sine theta over, there's still a -1, over sine theta minus 1. Okay, now let's go through and see. I have 1 over sine theta plus sine theta over sine theta minus 1. Oh, I think maybe now you can see where this is going. 1 over sine theta plus 1 minus 1. Those obviously are going to add to 0, and I have 1 over sine theta is cosecant theta. Woohoo! All right, thanks for joining. There's been a lot of information in this video, and I also went ahead and I'm going to post a practice in the links so you can go through and find the comment section, and I have 10 practice problems and I have the answers attached to that so you can practice on your own. Have fun!